Okay, so the other part about graphing that I did not talk yesterday. So we did the whole pirate plan of finding X marks a spot. Meaning when we have two lines that are going to intersect, that's going to give you one solution. However, there are two additional things that could happen. Okay, if they have the exact same slope, what's going to happen is you're going to have parallel lines. Okay, think of parallel lines just like rails on a train track. They are never going to overlap each other. Okay, if they do, the train falls off the track. It's a whole mess. But if there are parallel lines, they're going to run next to each other forever, but they will never, ever intersect. And because of that, that one's going to be a no solution. Okay, so I will kind of show two of those examples real quick, but I wanted to go over those ones. So if they have the exact same slope, but they are going from two different b values, they'll be parallel lines, they will have no solution. Okay, the other one is sometimes they will be the exact same thing. So if you draw the exact same line twice, your answer for that would be infinite solutions. I have both those examples I'm going to show you, but I didn't want to throw those into the mix yesterday. So I just want to make sure you figured out that they were exactly one solutions. Okay, so parallel lines means that there's no solution. And if they are the exact same line, it's infinite solutions. Some ways that you can write this if you want. No solution, you can write it like this, or you can have like a 0 with a line through it. Both of those mean no solution. It'll never, ever happen. And then if you want to write down infinitely many, does anybody know the infinity sign? It's a sideways, like figure 8. Infinitely many is written like that. Okay? So you can write infinite, you can write no solution, or if you want to write one of these symbols, these mean no solution, these mean infinitely many. Just kind of wanted to show you some of those math terms. Okay, I'm going to show those two types of examples, and then we'll get to solving the systems of equations algebraically. Today is going to be just a teaching day. It's a lot of stuff. We'll have a lot of practice. Tomorrow will be a work day. We'll have a worksheet. But today is going to be a lot of stuff. I just want to make sure that all this stuff is taught without having to rush through it. Okay, on to the two examples that I wanted to show you. Okay, so I've got these two problems right here. You guys have these parts down, so I'm just going to have you tell me. For the top one, that y equals x plus 4. What's my slope on that? What's my m value? Love it. 1 over 1. You guys are getting so much quicker, more confident with that, and I love it. What's my b value? 4. Man. Okay. I'll do the second one just while I'm at it. This next one, I've got y equals x. For this one, what's my m value? 1 over 1. What's my b value? 0. Man, I love it. All right, I'm going to draw that graph real quick. So I've got this kind of line here, this one going here-ish, pretend it's straight. All right, so my very first one, I'll start with that. My b value is 4, so I'm going to go up to 4. So 1, 2, 3, 4. My first point is there. And then my slope is going to be 1 over 1. So up 1 over 1, up 1 over 1. Or I could say down 1, left 1, down 1, left 1, down 1, left 1. That's my first line. My next one, it said b equals 0. So my first point is going to be right here. My slope is 1 over 1. So right there, right there. Up 1 over 1, up 1 over 1, up 1 over 1. Or down 1 over 1, down 1, left 1, down 1, left 1, down 1, left 1. The ending of my first graph, or my line wasn't great because I didn't draw it very straight. But do you see how these have the exact same slope? They start at different spots. They are never, ever going to touch. So if I drew this graph like this, what type of solution would I have?
Parallel.
Parallel. So was that going to be?
No solution.
No solution. Perfect. Yeah, you're right. They're parallel. So this one is going to be a no solution. So if they're parallel, there will be no solution. I got a feeling you guys know exactly what this last one's going to be, but I'm still going to do it. Questions on that one? All right, on to this one. Let me get some space in there. All right, so for this top one, I got y equals negative x minus 3. What's my m value? Negative 1 over 1. What's my b value? Just negative 3. Yep. All right, let me change up some colors to my pen here. We'll do that one just to be fun. All right, is this one set up in y equals mx plus b?
No.
What do I got to do?
Switch around.
Okay, switch it around, subtract some things. Anybody got an idea of what I should do first? So, not 2y. 2x, yep. Okay, so minus 2x to both sides. I get 2y equals negative 2x minus 6. Now I need to get y all by itself. So I'll divide 2 by both sides. So 2, and then all that stuff is going to get divided by 2. And I'm left with y equals negative 1x minus 3. So on this one, what's my m value? Negative 1 over 1. What's my b value? Negative 3. Okay. Time for me to graph. I've got this thing kind of here. All right, so my very first one, I'm going to use the blue one. It said my b value is negative 3. So I go 1, 2, 3, right there. My slope is down 1 over 1, negative 1 over 1, 1 over 1. Or you'd say up 1, left 1, up 1, left 1, up 1, left 1. All right, first line's done. My next one. Oh yeah, I was right. It was supposed to be negative 3. I just didn't write it right. My next value is going to be at negative 3. My slope is negative 1 over 1. Negative 1 over 1. It's on the same line. You can barely see because I drew it so great. You see how every single point's the exact same point? Okay, you guys probably figured this part out. What kind of line is this? Like, what's the solution for this one? Infinite. They're the exact same line. So for this one, there will be infinite solutions. Okay? So for this one, there will be infinite solutions. Okay, so good on that? All right, we're going to segue. Oh, these went too high. Let me see if I can drag those ones lower again. I can't. Lasso. That was fun. Okay. It really was. I thought it was super fun. Okay, so we did the graphing part. Thinking back to when we did algebra, do you guys remember when we had problems that used those symbols before? Maybe you do. Do you remember like what those ones look like? Not really. Okay, so like if I ever had a problem that said, oh, it's still stuck on lasso mode, so give me a second. If I ever had a problem that said 1 equals 8, could 1 ever equal 8? No, never ever. Okay, if it ever had something that looked like this, where it's like 1 equals 8, it can't happen. So that's going to be a no solution. If I ever had a problem that said like 3 equals 3, does 3 ever equal 3? When does that happen? All the time, right? So if it's the exact same number on both sides, infinite solution. The numbers don't equal each other, then again we have like no solution. But sometimes we can solve a problem and it could say something like x equals 2, right? So this would be like we would have one solution, no solution, infinite solutions. We are going to get to solving systems of equations, kind of like what we did with graphing, but now instead of using graph paper, we're just going to do it with the magic of math. All right. So, again, this is what the graphing stuff is. When we do the systems of equation algebraically, we will still come up with 3 types of solutions. We can get exactly one solution where it'll say x equals this, y equals this. We can get some that are going to be no solutions. We can get some that are going to be infinite solutions. And hopefully you'll be able to see those. So on to 9.7, solving systems of equations. All right, because it's going to be a big, heavy day, I'm going to hit pause on this.